Hi everyone, welcome back. This is the second part of lesson 4, the first lesson in our module. We just finished our do now, we found there's two solutions. Now we're going to go on and see the walkthrough of the example right below. So today one of our objectives is to find the solutions to quadratic equations that have complex roots, and we'll see what that looks like. Remember from fundamental theorem of algebra, we expect this polynomial to have two solutions because it has degree 2. I'll write that out. It's degree 2. So let's go on and apply our quadratic formula and see if this gets two solutions just like we expect. First things first, I'm going to make a list of our steps here on the left. First thing we need to do is to solve our equation for 0. That's the condition where the quadratic equation works. So let's do that now. To get this solved for 0, I notice this 2 is in the way over here. We'd like it if this 2 were a 0. So to make it into a 0, we're going to subtract 2. That'll make a 0 on the right side. Whatever we do to one side of the equation, we have to do the same to the other side. So if I carry out this, we get x squared plus 2x. 6 minus 2 is 4, equal to 0. Nice. So we did the first step, we solved our equation for 0. Second step is going to be get our coefficients. And that's our a, b, and c from our formula at the top, right up here. Let's do that right now. So our a, if I just match up our formula to the general form, here's our general form right beneath it. Now I can just match up and sort of highlight our coefficients. So a is going to be on the coefficient on the x squared term. Here, that's just a 1. We can imagine that that's 1x squared, so a is going to be equal to 1. B is going to be right here, our coefficient on the x term. Here, b is 2. And then c is going to be our coefficient on, or not our coefficient, our constant at the end, and it has value of 4. Nice. So we have our coefficients. We can check that off our list. And then our third step is to plug in and simplify. Simplify. Nice. Cool. So we have our coefficients. Let's get our formula. So our formula is down here right on the right. I'm just going to start by writing it out. I'm going to leave spaces where I'm going to plug in all of the coefficients like I did on the do now. So x equals negative. I'm going to leave a space for the b. We'll be able to plug it in. I like to leave the parentheses like this because it makes sure that when I plug in positive or negative or square root numbers that the order of operations will still be there. The negative is on the outside. So that's really important, making sure we don't make a mistake with our signs. Space squared, negative 4 times something, all over 2 times something. Nice. Now we got to plug in our b, our a, and our c. So let's do b first. I see b's show up. The first one, b is 2. Just put a 2 in there. B shows up here as a squared. And that's all of them. So now I'm going to go in and do our a's. I'm going to plug in the a's in red. There's an a on the bottom. A is 1. There's an a next to the 4. There's 1. And there's a c. We'll do our c's in green. C is 4. Cool. So we've plugged all our numbers in. That first half done. Now we just have to simplify. All right. So again, if you want to pause the video, try and take a couple steps here to simplify this down, and then fast forward to make sure we agree. But if you're going on, I'm just going to draw another line over here. X equals negative 2, keep that, plus or minus the square root of 2 squared is going to be 4, minus 4 times 1 times 4, that's going to be 16, all over 2 times a, which is just 2. All right, so if we go even a step further, we're going to get x equals negative 2 plus or minus the square root of, let's see, 4 minus 16. That's going to give me negative 12 all over 2. Now let's pause here and take a second and look at the square root of negative 12. If we were to go on to simplify, this is saying what number times itself. So something times itself would give us negative 12. And we get a problem here because say I have a positive number like 3. 3 times 3 would give me a positive 9. But I could try negative 3. I don't need it to be negative. I could try negative 3's. I have to use the same thing. So negative 3 times negative 3, that's also a positive 3. So off the top of my head, I can't think of any real numbers that, when squared, give us a negative number. So that's where mathematicians said, wait a second. We know there needs to be 2 solutions to this polynomial, but we're having a problem. We don't have enough numbers to describe what happens when we have negative square roots in one of our solutions. So what mathematicians did is they added on a bunch of numbers called the imaginary numbers. So to make up for this, they did plus or minus. Instead of it being a negative 12, they're like, this is now one of our imaginary numbers, so we're going to change this to be an I, and then leave the square root of 12 there. Okay. Now this form right here is actually 2 solutions. Let's write them out separately. Our first solution is going to be x equals negative 2 plus I times the square root of 12 all over 2. And also going to be x equals negative 2 minus I square root of 12 all over 2. So these are 2 solutions, and they are imaginary solutions. Because, again, we can't think of any real numbers that have negative squares. So mathematicians introduced the imaginary numbers to account for that. So down below, you'll see on your handout there's a summary of how to do this process, solving quadratic equations with the quadratic formula. And in particular, it gives an example that has a complex root. Now, I didn't simplify my answers very much. I just kind of left them as fractions with the square roots in them. In this example here, I give an example of how you could simplify the radical by pulling out a perfect square, and also simplify the fraction by splitting it up and reducing. So use this example as you go on to solve any more. The next thing you should practice is in your binder, exercise number 1, solving this problem. There's something just like this on the exit ticket that you're going to have to take to show mastery of this lesson. So take a couple minutes, practice out this exercise. In the next video, you'll see the solution.